In this video, I will be showing my knowledge of Chapter 6, which is about inverse and radical expressions and equations/functions. To start off, we're going to do Lesson 6.1, which is about function operations. So either you add, subtract, multiply, or divide two sets of functions. To start off with, we have this problem here. F of x, or function x, equals x squared minus 20, and function g, or g of x, equals 10x. The first question asks us to solve for function g times function f. Here's how I like to remember it. F goes inside of g, or function f goes inside of function g. So here's how we're going to do this. We're going to take function g, which is 10x. But now we're going to take function f and replace that with x. So this is going to equal 10, replace the x with function f, x squared minus 20. Then you're going to distribute the 10 to this polynomial here. This would equal 10x squared minus 200. That should give you your answer. So function g times function f equals 10x squared minus 200. The second one, we're going to do the complete opposite, but we're going to add one more thing to it. So we're going to solve for function f times function g, where x is going to equal 5. So function g is going to go inside of function f. So we're going to take function f, which is x squared minus 20. But now we're going to put function g in place for x in here, which is 10x. So this is going to be 10x squared minus 20. Now I said x is going to equal 5, so we have to place x with 5. So this is going to equal 10 times 5 squared minus 20. Now we're going to solve for what's in parentheses first, so it should be 10 times 5. So this would equal 50 squared minus 20. Now you're going to square 50. That's going to equal 2,500 minus 20. And when you simplify that, you should get 2480. So function f times function g, where x equals 5, equals 2,480. Now we're going to do lesson 6.2. This is about inverses of functions. So for this first one, it says, is this right here a function, and is the inverse a function? Well, let's figure this out first. If it's a function, it means every x value goes to a different y value. Now, is that correct here? 4 goes to 2, 5 goes to 8, negative 2 goes to negative 6. Each x value goes to a different y value. So yes, this is a function. But now we need to find if the inverse is a function. How do we find the inverse? Well, this is how you do it. All you do is very simple. You just swap the two around. So the inverse equals, you have 4, 2. You're just going to swap them around. So this is going to equal 2, 4, 8, 5, negative 6, negative 2. Now let's see if the inverse is a function where every x value goes to a different y value. By the looks of it, they do. This means that this is a function. Both of these are indeed functions. Now we're going to do lesson 6.3. This is about the square root functions and inequalities. So for this first one, we have y equals x plus 8. And we have to identify the domain and range. Here's how you find the domain. You take what's inside of here and you make it greater than or equal to 0. So here's what I mean. So you have x plus 8. X plus 8 is greater than or equal to 0. That is your domain. Oh, sorry, I'm getting ahead of myself here. Now you have to solve for this. So you have x is greater than or equal to negative 8. That is your domain. So your domain is x is greater than or equal to negative 8. To find the range, all you have to do is plug this back in. So whatever you get here, you plug it back into here. So you have negative 8 in place for x, so negative 8 plus 8 equals 0. Square root of 0 equals 0, so your range is y is greater than or equal to 0. Now, for this next one here, let me just adjust this. We have function f is equal to the square root of x minus 12 plus 8. All right, we're just gonna do the same thing here. We're gonna take what's inside of the radical here, and we're gonna make it greater than or equal to 0. So we have x minus 12 is greater than or equal to 0. This would equal x is greater than or equal to 12. That is your domain. Now to find the range, you plug this back into here. So you have 12, which is x, minus 12 is 0. Square root of 0 equals 0. 0 plus 8 equals 8. So your range, y is greater than or equal to 8. Now we're going to move on to lesson 6.4. This lesson is about nth roots, where if you don't get that nth, it's actually going to be here, because nth could represent any number. So here's how we do this here. So we have the fourth of the square root of 81 times quantity x squared minus 12 to the 16th power. Well, let's figure this out. So when it tells us to go to the fourth, we have to find the fourth root of 81. So here's how we do it. When you factor 81 out, you should get 3 times 3 times 3 times 3. Obviously, you keep this in here. Now, what this means, in order to have the whole number, you have to have 4 of the same number in order to make that a whole number. So we have 4 3's, so 3 equals 1. And then you have your polynomial here with x squared minus 12. And then what you do with this exponent here, you actually do this. I like to do this. 16 divided by 4. 16 divided by 4 is 4, so you'd make this to the 4th power. That is your answer, but here's what you could also do. You could also do this. This is also a correct way to do it. So you have 3, then you make this an absolute value of the quantity x squared minus 12. Sorry. To the 4th power. Either one of these is correct. That's how you do that one. Now we're going to do lesson 6.5, which is about operations with radical expressions. So the directions say to add or subtract the radicals. For this first one, we have the square root of 48 minus 6 times square root of 24. Here's how you solve this one. You actually have to factor these out. So let's factor 48 out first. When we do this, we can get 4 and 12. Factor 4 out, you get 2 and 2. You get 3 and 4, 2 and 2. All right. So you have one pair of 2, that's 2. You have another pair of 2, that's 2. 2 times 2 is 4. You have a 3 left. Root 3 minus 6, because you don't do anything with the 6. Now we got to factor out this 24 here. So we're going to do 2 and 12, 2 and 6, 2 and 3. One pair of 2's, that's 2. We don't have a pair of another one, so it's just going to be 2 Sorry, I messed that one up. Anyways, 4 root 3, terrible 3, minus 6. Now, since we have the pair of 2's here, so you have times 2 times the square root of 2 times 3, 6. So now you do this. 4 root 3 minus, so negative 6 times 2 minus 12 root 6. Now you can't simplify this anymore because the radicals aren't the same. So this would just be your final answer. 4 root 3 minus 12 root 6. Now for the second one here, now we're going to multiply 2 sets of radicals, yada, whatever. So first, we're going to distribute the 6 root 2 into both of these here. So 6 root 2 times 3 root 5. So you're going to multiply the whole numbers, and you're going to multiply the radicals. So this is going to equal 6 times 3, 18, 2 times 5, 10. Simple enough. Then you're going to multiply with that. 6 times 4, 24. 2 times 2, 4. All right, we distributed that. Now we're going to distribute the negative 3 with these two here. So we have negative 3 times negative 3, which is negative 9 root 5. Negative 3 times 4, negative 12 root 2. Now this is not simplified. Why is that? This right here. 4 can be squared. So this would equal 18 root 10 plus 24. Square root of 4 is 2, so this would be times 2 minus 9 root 5 minus 12 root 2. So your final answer would be 18 root 10 plus 24 times 2, which is 48, minus 9 root 5 minus 12 root 2. Now on to lesson 6.6. This lesson was about the definition of radical expressions. So this one here, as you can see, we have a normal looking problem here, but now we have a fraction as our exponent. Here's how you do this. That's going to be in your square root here. So, but this number 3, that's going to be your nth power. So 3, 8x cubed, y cubed. Now we solve this like we did in lesson 6.4. 8 can be cubed, so this is going to equal 2 times 2 times 2. Then you do the number of x's, so you have 3 x's and you have 3 y's. So this actually equals, so you have 3, because you need 3, so you have 3 2's, so 2. We have 3 x's, so x, and we have 3 y's, so y. So your answer to this problem is 2xy. For our last problem here, we have lesson 6.7. This is about solving radical equations. It's just solving an equation. Now we use everything, we learned, and we apply it here. So, first, the thing we would do is we get 8 to this side, so you would subtract 8, so you have the square root of 2x plus 2 equals 12 minus 8, which is 4. Now we have to get this radical away, so the inverse of this would actually be squaring this. So you have 2x plus 2, because squaring this, the square root of this is 2x plus 2. Square root of 4 equals, or 4 squared, equals 16. Now this is any other normal equation. So now you could subtract 2 from both sides, so you get 2x equal to 14. Divide 2 by both sides, x equals 7. That is your final answer.